Well, I would like to present the results of our research on the topic information system for real estate trading operations based on the data analysis. Authors are Oleh, Pavlo, Ilchuk, and Oleh Kots from the Polytechnic National University. Real estate transactions involve significant amounts of money, and trading decisions need to be made on the basis of relevant data. Correct valuations of real estate plays a main role in the trading process. Traditionally, real estate valuations has relied heavily on manual data analysis. Therefore, the use of data science methods to predict the value of real estate objects is relevant, as it will ensure transparency in the real estate market, reduce the cost of realtors and real estate agents, and enable users to make more efficient decisions regarding to purchase and sale. The implementation of artificial intelligence marked the beginning of the period of change impacted on the way real estate is valued and opened the door to extraordinary levels of accuracy, efficiency, and transparency. The dynamics of real estate market require the ability to adapt in real time, which artificial intelligence skillfully performs. Traditional valuations methods often rely on out-of-date data and are unable to account for market changes that occur rapidly. In contrast, artificial intelligence is able to smoothly incorporate changes in real time, which determines its absolute advantage. We can highlight the following advantages of using artificial intelligence in the process of determining the value of real estate. Enhanced precisions, time efficiency, cost reduction, integration of geodata, clear understanding, enhanced investment decisions. Detailed characteristics of these advantages you can find in our research. The most popular application for selling, buying, and renting real estate we were studied. You can see the logos on our slide. A significant advantage of DiMRIA and OLX is their popularity in Ukraine, which in turn has led to the fact that such services have a huge amount of real estate data available, which is constantly growing. In our research, we have done the comparative analysis of the developed system with competitive applications. We used a list of features for comparing and can say that existing applications in the Ukrainian market fall short of meeting all the user's needs, lacking sufficient functionality for recommendations and analytics. To be business process diagram is presented on this slide. It includes the use of information system, shows that the decision-making process for purchasing real estate has been greatly simplified and involves far fewer steps. After filtering the property of the specified parameters, the buyer can choose the options he's interested in. Also, we formed the list of requirements to the developed system, which include business requirements, user requirement, functional requirements, and non-functional requirements. Based on the program's tasks and functions, as well as the intended users and their capabilities, a use case diagram was constructed on Figure 2. This diagram visualizes the user and functional requirements of the system. The diagram shows four system actors: user, authorized, unauthorized user, administrator, and investor. Users can potentially elevate their role within hierarchy to access a broader range of functions if needed. Also, there was built a class diagram on Figure 3 for the part of the software system responsible for searching, filtering, modifying, and analyzing data, as well as for training machine learning models, testing them, and applying them to solve real estate valuation problems. Here are the diagrams that explain how the process of buying and selling real estate works for users of this system. Activity diagrams have been constructed that describe step-by-step the process of buying, Figure 4, and selling, Figure 5, real estate when using the system. We foresee that the process of creating a machine learning model is conditionally divided into four stages. First, you need to find all available data sources that can be used. This stage includes searching and downloading data, filtering data, checking if there is any missing data, data unification, determining the coordinates of real estate, supplement the geographical data of the property. Second stage involves identifying the minimal set of crucial features and parameters of real estate that significantly impact a machine learning model's ability to forecast real estate value. Third stage includes dividing data into two sets, training and testing, typically in 80-20 ratio. The testing data is chosen using cross-validation to ensure robust evaluation of the model's performance. At the fourth stage, it's necessary to evaluate the accuracy of the models using one of the quality metrics. After learning which algorithm will work best for solving this task, you should choose one or more of them and try to find the optimal hyperparameters. In this way, it's possible to achieve high accuracy of the model for specific tasks. To facilitate the implementation of the system, a microservice architecture was chosen for its ability to provide simplicity, flexibility, and scalability. The software product will contain three distinct interconnected services: the data providing service, the backend service, and the front-end service. Data providing service on Figure 7, and this service will be dedicated solely to data operations, including searching, filtering, and initial processing. Additionally, it will handle model training, testing, and real estate value prediction based on input parameters. Its responsibility also extends to regular data updates at specified intervals to monitor market dynamics and provide the application with current data crucial for advisement. Backend service, figure 8, facilitates the transmission of data to the data providing service using parameters obtained on the user to clarify property values. Additionally, it offers diverse functionalities for data analysis, processing, real estate recommendations, email notifications, data caching, and user authorization. The development of this component leverages the Java programming language and the Spring Boot framework. Front-end service, figure 9, will oversee the interaction between the application and end users. Its primary role is to visualize data using various methods, present information in a user-friendly manner, and ensure intuitive navigation and usage of the application. It will be implemented as a web application as it allows for easy support and distribution of this project, provides accessibility from any user device. To test the machine learning model, a validation sample of real estate data was created and tested to see how the model performs in predicting value compared to real data. Figure 10 shows the distribution of the absolute error of the predicted results in percentages. Upon comparing the coefficients of determination of obtained results, it became evident that the random forest algorithm outperformed the others. On figure 11, the red points shows the predicted by the model values, and the blue ones show the real values. Figure 12 illustrates the percentage of absolute error in forecasting real estate values. The average error stands at 8.49%, with a median of 1.9%. We can say that in general the model performs well. The results of the study indicate that it was successful. Figure 13 shows the interconnected containers of all individual services utilized in the system via Docker Compose. The servers launched successfully, affirming the accuracy of the configuration. In figure 14 and 15 are shown the results of the system that was successfully developed. It was verified that all services work correctly and successfully interact with each other. Data is correctly transmitted, stored, and displayed. Let's conclude. We examined both Ukrainian and international applications addressing the challenge of value forecasting and real estate valuation. A distinctive feature of our developed information system is that the model training process incorporates not only basis real estate characteristics, but also geospatial data. The process of creating a machine learning model is conventionally divided into four stages. The developed information system will optimize and accelerate the process of discovering optimal real estate for purchase, as well as facilitating its assessment for future sale. And real estate sellers will promptly evaluate their property worth based on parameters, locations, and dominant market conditions, while buyers will access a list of recommendation properties priced in line with their actual attributes to below market value. Implementation of the developed information system will be useful for buyers and sellers of real estate, as well as for agents and investors, simplifying their business processes. So, thank you for your attention.